Hello everyone, welcome back to another session of Verilog coding with me. So let's get started. So we are resuming this series after a very long gap. So let's see where we have left. So as you can see that we have left uh, at 2-bit equality. So we will be doing simple circuit A and simple circuit B now. So let's see what is it. So module A is supposed to implement the function Z. Okay, so this is a simple combinational circuit. We can do it very easily. So the basic is assign what is output Z equal to, and here you have given the what is it, functionality of the code. So x, input x XORed with input y, and this whole XOR operations is given to AND operation with input x. Output of this is ANDed with input of x. So let's submit the code. So as you can see, compilation process has been started. So as you can see, the status is success. So moving on to the next circuit, simple circuit B. Okay, circuit B can be described by the following simulation. So as we can see, there are three types of waveforms. So as we can see, input, the x and y are inputs and z is our output. So looking at it, we have to figure out like which gate is used, or what is the output circuit. So as you can see, by looking by the observation, we can see that when the input x and y are 0, we are getting 1, and when x and y input are 1, we are getting output still as 1, and for the different input values of x and y, we are getting the output as 0. So there is only one gate which show this following functionality, and that is XNOR gate. So let's see how we can do that. Assign output z equal to tilde. Tilde is what it does is inverts. So we can say inverting function, inverting symbol, x XOR with y, close the bracket. So let's submit the code. As you can see, compilation process is started. So as you can see, the status success, and here is the timing diagrams. Inputs source reference. There is no mismatch. So that's all for this today's video. Next time we will be seeing about combination of circuits A and B. That's it.